All right, this lesson is entitled Angles Inside and Outside of the Circle. So we're going to be learning about not only how to find central angles and inscribed angles, but ones that, as mentioned, are in the middle of the, or not in the middle of the circle and then on the outside. So there are a little bit of vocab we have to talk about first. Tangent and secant are both words that may be new to you, may not be. So let's first talk about tangent. Tangent lines are lines that just touch the circle at one point. Okay, so look at this example right here. If you see this arrow says point of tangency, this line right here is just going through the circle and it's just touching it at one point. Okay, it does not cross through more than once. We can also see it in this example right here. Here's a point where it's tangent. All right, these over here are not tangent because if you notice, this one's not because it doesn't cross the circle at all. This one isn't because it's not a line, it's a line segment because there's only one arrow. This one touches a line or circle twice, and so does this one. It passes through twice. So a tangent line is a line that passes through or touches, we'll say touches, the circle in exactly one location. Okay, so tangent lines are lines that touch the circle in exactly one spot. Okay? A secant line, our next example, are lines that touch the circle in two locations. Okay, so in this one, it's going through twice. It touches here and here. It's going through twice. It's touching here and here. Okay, so our diameter, our chords can be secant lines. Over here, these are not secant. This one's actually tangent because it's touching one point. Here, it's only going through one time. Here, it's not touching at all. All right, so secant lines are lines that crosses through twice. Okay. All right, what is an intercepted arc? We've looked at these before. An intercepted arc is just when you have two straight lines across a circle. It's the part where they cross at the intersection. So for example, here's a circle. Let me draw two lines coming out of it. This part right here that I'm about to shade in black is your intercepted arc. So it's the part of the arc that is formed by two lines crossing it. All right, so the part of the, I should say the part of the circle between two lines. Now it could be, they could be diameter, they could be radius, it could be anything, any type of lines. It could go through the entire circle, whatever. Okay, so it's the arc that is formed when two lines meet. It's that intersection between them. All right, next word, a chord. A chord is a line on a circle, all right, that crosses, that hits it twice. Sorry. So here's your circle. All right, and a chord would be, it could go through the middle, it may not, so it could be your diameter, but it is a part of a line where the two endpoints are on the circle. So it's more of a line segment, really. All right, so a chord is a line, the two endpoints are on the circle. These are all words that we are going to be using in this lesson and from here on out, so make sure that you understand what we're talking about with tangent, secant, intercepted arc, and a chord. All right, let's move on. Okay, so it says, oops, sorry. What is going on? Sorry, guys, please hold. All right, I'm back at it. I apologize. Okay, so our directions say in the following circles, angles intercept different arcs. Use the measures of the angles and the arcs in the pictures to fill in the following chart. Be sure to use intercepted arcs only. Okay, so here's some of the new stuff that we are going to be talking about. Okay, so let's take a look here. Circle M the angle that we're given is 25 degrees. Now, if you notice, these two are both secant lines, okay, because it's lines that are crossing each other in the circle, and they will cross the outside twice, all right, or I'm sorry, two secant chords. If you notice, where they cross is not in the center of the circle. All right, they're not crossing at the center. Okay, if you remember last time, we learned that central angles are equivalent to the arcs, but we don't know the measure right now because that's not a central angle. All right, so let's fill in this chart. The big arc, take a look at your two arcs. Where these two lines cross, we're going to look at the intercepted arcs here and here. Okay, because as we see our lines cross each other, they're forming those intercepted arcs. All right, so in this example, the bigger arc is 30 degrees. The smaller arc is 20. Okay, now I'm going to add them together. So 30 plus 20 is 50, and I'm going to subtract them. And we're going to come back and do stuff with this after. Okay, so we're just filling in the chart. 30 plus 20 is 50. 30 minus 20 is 10. Okay, all right, let's take a look at N. The angle that I'm given is 21 degrees. Okay, I'm looking at the angle measure, not the arc measures for that one. My bigger arc is 92. My smaller arc is 50. Okay, so when I add those together, I get 142 degrees. When I subtract them, I get 42 degrees. All right, circle P. The angle I'm given is 40. Okay, now notice here, my arc's a little bit different, but what's my bigger arc? It's 160. Smaller arc is 120. So I add them together and I get 280. Subtract them and I get 40. Okay, in the last example, Q, the angle measures 120. The bigger arc is 300. The smaller arc is 60 degrees. Oops, sorry, I wrote that in the wrong spot. 300. 60 degrees. So add them together, I get 360. Okay, that's the entire circle. I subtract them and I get 240. All right, so we just filled in our chart looking at two different arcs. Now, if you notice, sometimes there's angles here inside the circle and outside, and we're going to talk about what that means and how to get that information. So let's fill in some questions. The question says, in circle M, what do you notice about the measure of the angle and the sum or difference of the measures of the arcs? So circle M, the measure of the angle is 25. And how is that going to relate to the sum and the difference of the measures of the arcs? Okay, well, any relationship between 30, 20, and 25. I'm pausing because I'm making you think. What I notice is that the angle measure is 1/2 of the two arcs added together. All right, so it's 1/2 of the sum of the two arcs, of the big and the little. In circles N, P, and Q, what do we notice about the angle and the sum or the difference of the measures of the arcs? Okay, so looking at it, the angle is 21. The sum is 142. The difference is 42. In this example, I'm looking at 40. Sum is 280. Oops, guys, sorry I made an error there on that one. All right, we're not looking at the 120. I just fell into the trap of just looking at numbers. That's not the one we want. We want the arcs that are formed by the, let me use a different color. We want the arcs that are formed by the intercepted arcs, the ones formed by the lines. This one on the outside is not the one we're looking at. We are going to use it to help us, though, okay, to find this guy right here. Because when I add those two together, I get 280, and I'm going to subtract that from 360 to find that missing piece. So this arc is 80, so I apologize about that. Okay, so let's go ahead and fix that on our chart. The bigger one is 160, the smaller one is 80. Okay, so when I add those two together, I get 240, and when I subtract them, I get 80. That's much better. Okay, so going back to what we were saying, sorry about that, guys. Right here, 21, I see my relations over here. I notice that 21 is 1/2 of this, of 42. I notice that 40 is 1/2 of 80. I also notice that 120 is 1/2 of 240. Okay, so notice I circled those all in the last column, the big arc minus the little arc. Versus in my first example, this was 1/2 of this column. Okay, keep that in mind. And we're going to go back and kind of really focus on that. All right, so what do we notice? The angle measure is 1/2 of the difference of the two arcs. All right, well, how do you know, though, if you're going to do 1/2 of the sum or 1/2 of the distance? It matters upon where the information is, what types of lines and chords and all that stuff you're looking at. In our first example, if you notice, they intersected on the inside. Okay, they intersected on the inside right here. In these, they're intersecting, and that my angle is on the outside. Okay, so keep that in mind. We're going to use that in a moment. Let's go ahead and change the page. All right, so it's kind of just recapping. That says, so what happens when two tangent lines intersect, two chords intersect, two secants intersect, or any two types of lines intersect, an angle is formed. Whenever any type of line crosses, angles are formed. We're now going to learn what the relationship is between these angles and their intercepted arcs. The key is to find where the vertex of the angle is located, meaning is it inside or outside? That is the big key, kind of we just talked about. Inside or outside. Okay, so if the vertex of the angle is the vertex of the angle on the center of the circle, on the circle, inside or outside. We've already looked at on the center and on the circle. Okay, that's what we did in the first two lessons. If it's on the center, we know that the arc equals the angle. The measure of the angle equals the measure of the arc. Okay, so that means that this is the same as this. Let's write that in better words. Oops. Angle measure equals arc measure. Okay, when it's on the circle, we looked at that. The angle is 1/2 of the arc. Okay, so if this guy is x, this one out here would be 2 times x. The angle when it's on the circle is 1/2 the measure of the arc. All right, well, here are new ones. Outside the circle and inside the circle, keeping in mind not the center. Okay, that's totally different than the first one. Okay, so when it's outside the circle, what did we notice happen? Well, let's take a look back here. When it was outside the circle, the angle measure was 1/2 of the difference of the arcs. Okay, it's 1/2 the difference of the arcs. Okay, so it's 1/2 big arc minus small arc, little arc. Keep it the same. All right, or you could say big arc minus little arc divided by 2. Okay, 1/2 multiplying by 1/2, same thing as dividing by 2. All right, inside the circle, not on the center. Take a look back here real quick. What happened? We noticed that the angle was 1/2 the sum. All right, so how can we keep track between those two? Because it's very similar. We just got to remember, are we adding or subtracting? When the two lines cross inside the circle, use your imagination. Think of this. This is a plus sign. All right, when the two lines cross each other, it makes a plus sign, so you are adding. All right, so those are our new formulas. We've already learned about angle measure equaling the arc measure. We already learned that an angle is 1/2. An angle on the circle is 1/2 the arc. So when they cross on the outside, it's 1/2 of the big arc minus the little arc. When they cross on the inside, it's 1/2 of the big arc plus the little arc. Okay, so here's what I want you to do right now. On your own, identify what type of relationship each one of these is going to be. So we have 7 examples. I can count. And write the formula next to it. Okay, I'm going to pause the video and do the same. So I want you to identify, is it a center? Is it an on the circle? Is it an inside? Or is it an outside? So go ahead, pause the video, identify that, and see if you can remember the formulas. All right, so take a look. I just went and filled in the boxes of 4 different formulas. Formula angle equals arc, angle equals 1/2 arc, angle equals 1/2 the big arc minus the little arc, and I put an O, so remember I'm thinking outside, and then 1/2 big arc plus little arc for inside. Okay, so the first example is the only one that says central angle. The second example is the only one that is a angle on the circle. Examples 3 and 6 are both outside ones, and then 4, 5, and 7 are inside ones. Okay, so it says using circles 1, 2, 3, and 4, identify how the angle is created, where the vertex is, and the formula used to identify or to find the angle. Okay, so take a look at circle 1. What types of lines are these really? Okay, well, we have chords. We have 2 chords, and they are secant. So we have 2 chords, and they're secant, okay, because they're crossing each other, and they cross the line twice. The vertex, where is it? Is it on the circle, on the center? Where is it? Inside or outside, I mean. It's inside, okay? They cross each other and form angles inside. So what do we say the formula is for an inside one? We said it is 1/2. In this case, let's use the numbers or letters we're given. So it's 1/2 the big arc plus, because it makes our plus sign, the smaller arc. So it's 1/2 x plus y. Or you could say x plus y divided by 2. Same thing. All right, circle number 2. We have tangent lines, okay? Tangents, they are chords. And they're tangent, okay? Tangent chords. All right, so our formula is, oh, sorry. All right, so our vertex is outside. Here's our vertex. They're crossing on the outside. So our formula is 1/2 of big arc minus, all right, big arc minus little arc, so x minus y. Or you could say x minus y divided by 2, same thing. Okay, looking at the next one once again, these are actually, going back. All right, noticing they are on, the vertex is on the outside, okay, but these aren't tangent, they're actually secants. Why? Because they're crossing through our circle twice, so we could say they're secant and chords. All right, vertex is on the outside, so our formula is 1/2 of x minus y, or x minus y over 2. The last one, I have a tangent and a secant. Tangent is this one. It's just touching once. Secant is going through twice. So a tangent and a secant, okay? So my vertex is outside, again. So it's 1/2 of x minus y. Okay, got to know those formulas. All right, so recap. When the angle is outside the circle, the formula to find the angle is big arc minus little arc divided by 2. When it's inside, it is big arc plus little arc. So when they cross inside, they form that plus sign. Divided by 2. All right, let's do some practice. We're going to do a couple of these together, and then some of them you're going to try on your own. We'll finish in class because our video is running a little bit long. All right, so let's start from the beginning. Find the degree measure for each of the number angles. First thing, decide, is it a center angle, an angle on the circle, inside or outside? So take a look at number 1. This one is on the circle, okay? On the circle. So remember what that means. This is 1/2 of the arc. So it's 1/2 of 54. So x equals 27 degrees. All right, number 2. Same type of example. It is 1/2 of the arc. Okay, the angle is 1/2 of the arc. Now notice in this one I'm finding the arc, so keep that in mind. Okay, but this angle is on the circle, so it's 1/2 of the arc. So if the arc is 2 times bigger than the angle, that means the arc is 70 degrees. All right, number 3. Where is it? It's outside. So think of your formula. Big arc minus little arc divided by 2. So we got to find the measure of those arcs, guys, in order to find the angle measure. All right, the big eye is 120. We need to find the measure of the smaller arc. Okay, so how are we going to do that? Well, look, you have all the other numbers. You have 90 plus 120 plus 100. So we're going to add those three up and subtract it from 360 to get this arc right here. So 100 plus 120 is 220, plus 90 is 310. Okay, so when I subtract that from 360, I get 50. So that means that x is going to be 120 minus 50 divided by 2, which is 70 divided by 2, which is 35. All right, I'm going to have you try number 4 on your own. Careful there. And number 5. Okay, let's take a look at number 6 together. Outside. It's an outside one. This arc is 220. So what's the other arc? Well, guys, if you notice, since this is tangent, the other arc is my little arc from here to here. So in order to find the measure of the little arc, I'm going to do 360 minus 220, and I get 140. Okay, so that being said, x is going to be 220 minus 140 divided by 2, which gives us 40 degrees. All right, let's do a couple insides together, and then we'll stop for that for now. Take a look at 7. This is inside, and what's important to notice, guys, it's not crossing on the center. We're actually not even given the center, but don't assume it's a central angle. Okay, so we have these two arcs out here. Okay, we need to find the measure of x. Okay, how are we going to do this one? Because we're not given the arcs on the outside, the intercepted arcs that we need. So what we can do is this, okay? We can find this angle right here and subtract that from 180 to get x, because those two are supplementary, they're on a line. So I'm going to do, this is an inside, so I'm going to do add my arcs, because I make a plus sign, add them and divide by 2. So 125 plus 117 gives me 242, and when I divide it by 2, I get 121. So that means that angle is 121, so to get x, I have to subtract from 180, so I get x equals 59 degrees. All right, guys, we're going to stop there. I know there's many more examples. Try some on your own if you want to. We will go over these in class, but give them a shot.